Hey everybody, it's Mrs. McGurkin. I wanted to take a minute to talk about the CER method for scientific explanations because we had a lot of people who were out yesterday. So after our first Is It Alive lab, one of the things that we need to think about with wrapping up an experiment is how to talk about it. And the CER method is the way we are going to wrap up a lot of our labs and activities this year. So CER stands for claim, evidence, and reasoning. And we're going to talk about what each one means and how we can apply it to what we did in yesterday's lab and labs throughout the year. So first of all, our claim is the statement about the results of an investigation. So you're going to approach this in a few different ways. So first of all, the claim is a one-sentence answer to the question you investigated. So this can kind of relate to your hypothesis as well. Next up, the claim answers the question, what can you conclude? So think about what was like the ultimate goal of this experiment and what can be one sentence way to wrap up the experiment. Next up, don't start it with yes or no. Just state your claim in a one sentence statement. And then it will describe the relationship between the dependent and the independent variables, okay? We didn't really focus a lot on independent and dependent variables for this particular lab because we were just doing an observational lab, okay? So one of the things that you could think about, a way to state a claim for the particular Is It Alive lab that we did is chemical reactions exhibit some characteristics of life. So that would be a claim that we could make about yesterday's experiment. Okay, so that is the claim of our experiment. Next up, we have the evidence. So evidence is our scientific data that's used to support the claim. So we need to think about the evidence in three ways. First of all, the evidence must be sufficient. So it has to be enough evidence to support the claim itself. It needs to be appropriate. So you have to use data that supports your claim and just leave out the extra stuff that doesn't support the claim that you have made. Also, and lastly, you have to use qualitative or quantitative data or a combo of both. So qualitative is using the senses. So in this particular Is It Alive lab, we use both of these. So we made observations using our senses, so that is our qualitative data. And then we used quantitative data, so that would be our temperature readings that we took as our quantitative data. So we used a combo of both in this particular lab, okay? So our evidence statements are just kind of like little bullet points. So first of all, one of the things that we noticed is that the wire reacted to silver nitrate. So that would be a stimulus response in terms of our characteristics of life. We could also say that the wire had crystals on it and there was some sort of color change. And that was also the response that was made. The crystals grew on the wire, so that does show growth and development. And if we go back and look at what happened here with our crystals, they grew and changed over time. So again, that does support some growth and development. The solution slightly went up in temperature, but only slightly. So that does show homeostasis in a way, because the solution didn't make extreme temperature spikes. It went up maybe 1 or 2 degrees. Lastly, we had changes that occurred to our wire over time, which shows development, not evolution, because we didn't have enough time in this experiment to indicate evolution. Okay, so the basic experiment here is we had a chemical change that used silver nitrate, which is this over here, and we added copper wire. And what occurred is that the copper and the nitrate decided to get together, and what was left growing crystals on the wire was the silver. So this was a chemical reaction, which is what happens during metabolism. All right. So the last thing that we do in the CER method is called reasoning. So with reasoning, this is what helps to tie together and pull everything together that you just did. So it ties together the claim and the evidence. So some key things to remember about reasoning is it shows how or why the data counts as evidence to support the claim. Next up, it provides the justification for why this evidence is important to this claim. It includes one or more scientific principles that are important to the claim and the evidence. So this is where we bring in the things that we're learning in class to help it tie to the evidence itself. All right, so we started writing about this. Again, we made our claim here so that chemical reactions exhibit some characteristics of life, but not all, because they're not living things. Okay, so again, we showed one of our pieces of evidence here. The wire reacted to the silver nitrate, and that was our stimulus and response. It had crystals and a color change. So something that we could think about here for our actual reasoning and how to write about it is that we can start by restating our claim. A chemical reaction can show some characteristics of living things. The characteristic of growth and development and stimulus and response was evident as the crystals grew on the wire and changed appearance throughout the lab. Also, the wire reacted as it was added to silver nitrate, which shows a stimulus and response. We did not have all of the characteristics of life present because a chemical reaction is not a living thing. Okay, so that would be a way that we would kind of wrap up the lab. That's obviously abbreviated version, but you would put way more information in when you're doing this reasoning piece. Okay, so hope this was helpful. Thanks for tuning in.